Hello everyone, it's me, Carolyn again. And in this video, we are going to talk about the mean, the median, and the mode. Some very commonly used ways of getting a feel for what the middle, and I'm going to put middle in quotes, because it's not necessarily the true middle. It might be like the trying to figure out what the most or kind of a central idea, someplace in the center, what that kind of means. And we do have three different ways to kind of measure the center of data. And one of them is the mean. And you probably heard of these things since, oh, I don't know, sometime in grade school. They start introducing these ideas. So first of all, the mean, which is another way of saying average. It's just another term. Um, what we have is we do consider finding the mean or average of a sample. So remember, we've talked about populations and samples. We use the symbol, this X with a line across the top, which we read as X bar, to represent the mean of a sample. If we are using the mean of the population, we will use a different symbol, this funny looking U, which actually happens to be the Greek letter mu. Now, you may know that to find the average, you add up all your data values and divide by however many there are. And that's exactly what this formula that's written here states. So first of all, this symbol, this funny looking E-like thing, first of all, it is a Greek letter. It is a Greek letter sigma, and it means to add up. So we are going to add up all of our little X, and X is going to represent a data value. So when I have these sigma of X, it means to add up all my data values. Then I'm going to divide by this, what we have here is an N. And N is the letter that we will use all semester long to represent the sample size, or how many items are in our sample. So just kind of keeping track. We will see this symbol over and over and over again as we progress through this course. We will also see this mu as well. I usually make mine a little bit differently. My mu looks probably backwards from that one, but that's how I kind of make my mu. It is just a Greek letter, so just kind of remember that. So we're going to add up all our data values, divide by however many there are. Another way to measure the center is finding the median. And the median is the actual middle value of our data. Kind of like the median, when you're talking about roadways, is the area between two highways. So this is going to be the middle of our data. So first thing we have to do is arrange it in order. So we don't want to have like the middle one that came to us, but the middle in sequential order. So if we have an odd number of data values, we will have an exact middle. If we have an even number of data, we're not going to have a real middle number because we'll have an even, so we'll divide it into two pieces. And the median will be the average of the two that kind of sit along each side. And we'll kind of look at a couple of examples as we move through this material. The mode is the value that appears to be most often in the set of numbers. So if we have a most commonly occurring value. So we're going to start with an example. I am going to do this one a couple of different ways. I am going to do it by hand, and I'm also going to use Google Sheets to show us how to do that. And then we'll come back to looking at how to do this as well. But first of all, we're going to find the mean, and we're going to find the median, and we're going to find the mode. To help me, I am going to order my data because I will need to do that for my median. So I'm going to put them in increasing order. So my smallest value is a 16. Then I go to 22. It looks like I have 36. Looks like I have two 37s. I have a 39. I have a 48, a 55, and a 61. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 data values. So the first thing I'm going to do is add those values up. So I'm just dragging out my calculator. And I'm going to add up my values, 16 plus 22 plus 36 plus 37 plus another 37, 39, a 48, a 55, and a 61. And I come up with 351 is my sum of all those values. And I'm going to divide by the number that I had, and we had 9 of them. So I'm going to divide that by 9, and I get the number 39. My median is going to be my middle value. So I'm going to kind of find my middle. So here's my middle value, 37. And my mode is the one that occurs most often. And my number 37 appeared twice where everything else was just once. So 37 is also my mode. Before I show you how to do this in using Google Sheets or Excel, because they're very similar, I just have a couple questions. Is it possible to have more than one mode? The answer to that is yes. Suppose in this example, we had another 22. Just suppose if there were 10 data values instead of the 9, then we would actually have 2 modes, the number 22 and the number 37. We just list them both. We also say that this is bimodal, which is exactly the same term we used when describing our data. Because if I graphed this data using some sort of dot plot, I would have 2 peaks, one at 37 and one at 22. Is it possible to have no modes? The answer to that is also yes. And that happens when each value occurs the same number of times. Same number of times. Okay. If we have a really large number or a really small number compared to the rest of our data, which of these 3, mean, median, and mode, would be affected? So let's say I added another data value up here of 1254, so 1,254. Which ones would be affected? Well, the mode's not going to change because there's still 2 37s as opposed to just one of everything else. So that does not affect anything. The median's going to move a little bit. It's going to now be the average between those 2 because we'd have 10 values instead of 9. So we'd have to average 1, 2, 3, 4, 5, 6, 2. Yeah. Average those 2, or maybe I'm up ways. Yeah. So we'd be at a 38 instead of the 37. So it changes a little, but not a whole lot. If I added the 1254, my sum changes quite a bit. And dividing now by 10 instead of the 9 will also be quite large. So the thing that is affected by these really large and really small numbers is the mean. And you'll notice by putting this large value up, my mean is going to be pulled up, or what we would say is skewed to the right, or positively skewed because it's going to slide up towards that right. Same idea when we were talking about how to describe these values. We'd also have a little tail floating out up there. So this terminology does repeat itself and they are connected. So just kind of be aware of that. I am going to switch to my Google Sheets now here. Just give me a moment. And I have typed in our data that we had already calculated the mean, median, and mode, but I wanted to show you how to do this, at least in Google Sheets. If you're doing it in Excel, it's a little bit different, but not dramatically different. I have kind of typed in the data. And what I'm going to do is calculate my mean. To do that, I'm going to be adding a function. So in Google Sheets as well as Excel, you can go to this little FX button that's kind of up here above the spreadsheet. And if you click on that, I guess it's not, forgive me. If you clicked on that in Excel, you'd get a little pop-up window. Here we need to actually insert a function. You can do so also on the main toolbar up here as well. So you can do a function is here. Functions, I usually go into our statistical. If you are using Excel, you get this little pop-up menu and you'll have these little categories. You'll go into the statistical category and then you will see you won't see a list, but you'll have a drop-down menu where you can scroll just like we do here and get at our different functions that we have or formulas that we have. When we're talking about the mean, we will be looking for the average. If you kind of hover over it, it does give you this numerical average of a database, ignoring, and it goes into more detail. But I am going to click on this. And what it's looking for is two values, like where I'm going to start and where I'm going to end. So I'm going to go grab my data. And now you'll see this little A1 and A9 pop up. It's telling me that I'm going to find the average of those values. And as soon as I hit enter, there's the 39 that was my mean, which happened to be the exact same thing that we got before. I'm going to do this again for the median and the mode. So I'm going to do it the shortcut this time. There is a function button on the toolbar in Google Sheets, and I'm going to go into my statistical. So I have to kind of scroll down, and we are looking for the median. So this is alphabetical. So I'm going to go to median. There's my median. Again, it's looking for the first values where you want to start and stop. So my A1 through A9, and I'm going to hit enter. And you'll notice there's our median, which was 37. I'm going to do it one last time for the mode. So there's my mode. And actually, I'm going to go back. I'm going to pick a different one. There's a few modes. I'm going to bring them up here so you can see them. We have a mode multi, and we have a mode single. I tend to like to use the mode multi because if there's more than one mode, it will give me both of them or all of them. So again, I'm going to highlight my data and hit my enter. We only had one mode. If we had more than one, it would have printed them going vertically down. So you would have seen all of the different modes. Okay. I'm hoping this little short thing helps you, because I mean, right now our data set is very, very small. In the future, data sets could be larger in your real world. In our class, we will actually be using SALT sometimes. And when you do that, it'll take the data right in there for you. And I will actually show you how to do that in our next video when I do the standard deviation. I'm not going to show it to you here, but I will show it to you in the next video. I'm going to go back to our notes and finish those up as far as talking about mean, median, and mode, because there are different applications of them. So sometimes, I mean, we have these three measures and they are all useful in their own right. So, but however, sometimes it is better to use one over the other because it's like, why have three? Well, they all serve their purposes. So first of all, if we have numerical data, numbers that mean something, the mean or the median should be used. So if we have numerical that is qualitative in nature, we want to use the mean or the median because that would make most sense to find our middle average or the middle value. If we have outliers or very large numbers, very small numbers, we probably don't want to use the mean to describe our data, as the mean is going to be pulled and distorted by those very large or very small data values. So that's when we would use our median. If we don't have really large numbers or really small numbers, like outliers, ones that are different from the rest of the data, we would probably use the mean. If we have categorical data like hair color and things like that, we were going to use the mode, because that's going to tell us how the most common piece of information is. And we really can't get at a mean or a median, because we can't add hair colors and then divide by however many we had. So just have to be a little bit careful. So we're going to go through just a couple of examples here and just determine which would be the best and why. So I have a data set with some numbers, and they are in order just to make it a little easier. They ranged from 75 up to 100. I would say that we don't really have any really big numbers or really small numbers. So I would tend to use the mean to kind of estimate that middle central piece. Here we have different crops and how many acres they are being grown on. So we have 25 acres of barley. And so we want to kind of know what the central crop is. Here I would use a mode. And I would be able to say that our most common crop is the soybeans. In this last one, if we're trying to find the middle salary for football players, and I'm going to put middle in quotes. So if I'm trying to find the central or the average football playing score or average salary, I probably do not want to use the mean, because I would have some football players that make quite a bit more than the rest. So here I would like to use the median and find that actual middle value. That would be a better representation of the center value for our football players, for their salaries. So again, even though we have 3 different measures, sometimes we can use all 3. We can find all 3 of them, but sometimes it makes more sense to use one over another. We do have another application of our mean, and this is something that you guys will see in my class, especially as well, is something called a weighted mean. And a weighted mean gives more weight or more importance to some values over other values. And these weighted mean has a formula. Again, we're using X bar, which is our average. We're going to be adding up our data. These W's are the weights. And in these problems that we'll be seeing is they're going to represent percentages. So those will add up to 1. Also, we're going to take those weights and multiply them by that value. So these are the values. Okay. An example that I'm going to show you is, first of all, grades. And there are a lot of teachers that use weighted grades. For example, this particular teacher, 60% of your grade comes from your tests, 30% comes from the quizzes, and 10% comes from homework. There are other classes that might give you some percentage for participation or attendance and things of that nature. So note that the pieces with the largest value carry the most power, or are more important than the other pieces. So if I'm going to calculate her overall average, we're going to need all those pieces. So we have her test average is an 85, her quiz average is a 90, and her homework average is a 70. So we're going to take our weights, so here's our little formula, multiplying them by their value, And then we're going to add them all up. So we're going to have our tests. The weight of a test is 60%. So that's going to be like a 0.60. And we're going to multiply that by my 85. To that, we're going to do our quizzes. Our quizzes have a weight of 30. So 0.30 times our 90 plus our 10% times our homework, which she has a 70 on. And now I'm going to multiply my pieces together. So we have to remember order of operations tells us to multiply first before adding. So we're going to multiply those pieces here. So this gives me a 51. This gives me a 27. And this gives me a 7. And I'm going to add those numbers together. Oops. Got to type in the right button. And I get an 85. So this is her overall weighted average. And you'll notice that even though she did get a 90%, it didn't pull as much weight as her 85 test scores. So 51 points came from her tests, 27 points came from her quizzes, and only 7 points come from the homework. If you want to think of having like 100-point test, 60 of those 100 points is going to come from her tests. 30 of those 100 is coming from the quizzes, and only 10 comes from the homework. So if you're trying to prepare for things, we want to make sure our test scores are pretty good. Okay, we're going to do one more example here. And so we're working on improving the design of USB flash drives. And we kind of try to figure out how many gigabytes we want to put in this flash drive. So what they did is they found that 5% of people want a 16 gig, 36 want a 32, 22 want 64, 37, 128. And so we want to find the average value of those pieces. So we want to find the X bar for all of this. So 5% is going to be that weight. This is the value. Another way to kind of think of this problem is if we had 100 people and everybody had their preference as to how many gigabytes, we would have 5 people that liked a 16 gig. So we would be taking a 16 plus a 16 plus a 16 plus a 16 plus a 16 for those 5 people. Then we would add on 36 32s. We'd add on 22 64s, and so on. We'd add all those pieces up and we'd divide by our 100 people. Shortcut tells me I can take this 0.05, multiply it by my 16, add it to the 0.36, multiply by the 32, add it to the 0.22, multiplied by the 64, add it to the 0.37 times the 128. So again, we do our multiplying first before we do our adding. So I'm going to get these pieces. So 36 times. So this gives me 11.52. 64. 14.08. And 47.36. And then we're going to add all of these values up. And I come up with a 73.76. So if I were making a new flash drive, I'd want to have roughly, I'd say probably 74 gigs of data, if that would make even sense. However, in computer standards, not so much. We like the 16 gigs. It's like multiples of 8, to be honest. So it's like 8 was your smallest, and then 16 came out, then they doubled that to give you the 32. We doubled that to get the 64. We doubled that to get the 128. So if we could create a 74, that would probably be the one that would please most people. But anyway, some things to kind of keep in mind when you are calculating means, medians, and modes is looking at your data. And your mean has to be somewhere between your smallest value and your largest value. So try to keep that in mind when you're calculating them, because if you get something that's too big or too small from as compared to your data, you probably made a mistake. So if maybe you divided by the wrong number. So double check those things. So if you have any questions, please contact me as you're working through the material. I hope this helps you get a better understanding of our mean, our median, and our mode. We will be doing more of them, and good luck in your homework. Have a great day.